So a position vector, different than a vector, actually has a starting point. And we often have our position vector starting from a fixed point, such as our origin, and so that vector is O to P. So this vector doesn't fly all over the place and can be just anywhere. It's specifically starting at O and ending at P. So you can write this, you can underline this, or label it by whatever the coordinates of P are. So we want to sketch a position vector passing through the point -6, 5. So it would start at our origin and go to the point -6, 5. And write that position vector in two different ways. Well, we could write it with our unit vectors, or we could write it as a column vector. So any point with coordinates x, y becomes a position vector with that vector x over y. Resultant vectors. Yeah, go back for a second. So we're going to draw A and B, and we can draw both A and B as position vectors. So A is in blue, B is in green. If you wanted to go from A to B, that's called the resultant of the vectors A to O and O to B. So in vectors, if you want to start at one place and go to another place, you can always first go back to the origin and then go from the origin to the point B that you wanted to go to. So we can always use our position vectors to write any free vector or any other vector that we have. So if I want to write the vector from A to B, I can write it as A to O and then O to B. And with vectors, we're not worried about necessarily how far we have to travel, right? I mean, if you're at your house at part A and you want to go to your friend's house at part B, probably you would go directly there. That would make sense. But you would still get there if you decided to go somewhere else first and then go to their place. And that's, vectors are not necessarily worried about how you get there, just that you started at one place and ended at another place. And so with our vectors, well, A to O is the same as negative O to A. That was one of the properties that we learned. You could go in the same way, but the opposite direction is just putting a negative in there. And so our resultant vector from A to B is just like, and I actually often really like, even though it's in all the formulas like this, B minus A, I really like to write it as negative A plus B. Does it make sense? If I start from A, going back to the origin is like going negative A. And then going from O to B is like going plus B. So I like to think of it as negative A plus B. I guess these should be lower case letters, but that's fine. But you can write it as B minus A. As far as doing the math, B minus A is easier to do than negative A plus B. But as far as seeing what we've done to go from A to B, I think it's easier to see negative A plus B. So this is just the idea. You can memorize this, that The vector a to b is just b minus a, or you can remember it as negative a plus b. Either way is fine. So we'll do a couple examples here. They don't take that long. So you have coordinates of a and b. If you want to find from a to b, what do I have to do? Again, I've got some point in 3 dimensions. Here's a, there's b. You can think, go back to your origin and then go to b will be the same as going from a to b. So if you can imagine this, you can say to yourself, well, this is negative a and this is positive b. Or you can just do b minus a. And when subtracting 2 column vectors, the vector that you get is just combining the x coordinates, the y coordinates, and the z. So 4 minus the negative 2, that makes 6. Negative 3 minus 7, that makes negative 10. And 2 minus 5, that makes negative 3. So as far as the mathematics, actual computations go, you're just adding and subtracting values here. So if you know what a to b is, well, b to a using the properties is just negative a to b. And you get negative 6, 10, 3. So this is just a summary of the same thing, just using different letters, right? If you want to go from Q to R, you can go negative of P to Q, or you can just go Q to P, and then go from P to R. Color coding this, Q to P, or P to Q, that's our blue. P to R is our green. And what we're trying to find is our red line there. And you could, even if you wanted to, add more vectors. You could have a whole bunch. Like I could add another point over here and call it point PQRS. Does that look S-like? You could go from Q to S, then S to P, then P to R, and it would still be equal to Q to R. So if we know what x to y is, and we know what x to z is, how do we find y to z? So there's a picture. You know what x to y is, you know what x to z is, and you want to find from y to z. Can you see that you would need a negative one of those and a positive one of those if we started here and ended there? And then once you find y to z, z to y will just be the opposite. Okay, that's where we're going to end.